Hello everyone, welcome to week 5 of social network analysis in education. And even though we're still in week 5, which is pretty surprising given the amount of work you've already produced in this class, I want to first thank you for the efforts you've made so far in this class and the tremendous amount of contribution you've made to this class. And I think you've made a lot of progress in terms of social network analysis. And I've learned a lot from you as well. Either it's from the area of expertise you bring into this class or the different way of looking at social networks that you introduce to the class. Because whenever we do a social network analysis, we have specific, sometimes underlying assumptions that we bring into the analysis. And by looking at your work, many times I get surprised because I don't usually see networks in that way. And so in the future weeks, I wish to keep learning from you as well by just keep interacting and keep sharing in the class, and hope you would do the same thing and really appreciate this kind of group interaction. That's tremendously fundamental, I think, for any kind of learning, especially in a class like this. So in the meantime, I also want to encourage you to get in touch with me if you have any kind of questions or any kind of concern about this class, and I'm more than willing to accommodate any kinds of requests from you if possible. And for this week, we're going to get into more technical side of social network analysis. And the first thing I want to really quickly talk about is about sociograms. And you've produced a lot of pretty beautiful visualizations last week. And right now I'm just going to go through some examples and to point out some, I call it graphical devices that are important for visualizations so that we can use this opportunity to ground additional exploration you would do this week. And for example, what you see right now is one of the examples you produced, and here you see there are a bunch of nodes and a bunch of edges. And one important graphical device you see here is the size of the nodes. And the size of the nodes is used to convey some kind of attributes or attribute data of each node. For example, bigger nodes, I suppose it means more connections, and smaller means fewer connections. And this is one of the very typical use of the graphical device of the size in social network analysis. And if we keep going to this one, and you see even though the size of the nodes are all the same, the edges here are represented as arrows. So the arrow are used to represent the directions of different kind of edges. This is another important device you will see in visualizations. And here you see the use of colors. Colors are really important graphical devices in any kind of visualizations. And you see right now it's used to represent maybe different types of nodes. Even though when we get into details of network visualization, you will see colors could be used to mean to represent categorical data, and sometimes it's used to represent scale data. For example, from number 1 to 100, you use a lighter color to represent 1 versus a darker color to represent 100. Versus in a different case, if we see right here, you see the colors here are used to represent group membership. So there are many different powerful use of colors that you can explore in social network analysis or social network visualizations, and you will keep, I think you keep tweaking to learn more about the usage of colors. And I think that's all to maybe just to ground the work of this week, and also to appreciate the work you've been produced in this class. And right now I want to give a quick overview of week number 5, and just to guide you through some kind of expectation for this week. So for this week, the first part, as you can see on the website, is about sociograms and network visualizations. I think this is critical because it's widely used to help researchers understand networks, especially in exploration phase of any kind of social network analysis. And there are critical decisions you need to make when you're producing sociograms. And if you come up to this this page here, I've highlighted the importance of knowing what's the goal of making this visualization. That's usually the starting point of making a sociogram. Are you trying to communicate, for example, positions and of key players in the networks? Or are you trying to understand how information will flow across networks? Or how are you going to show people from different places how they're interacting? I mean, for example, the example you see below, they are not necessarily drawing from a force directed layout, which is maybe the most popular layout you see, but they're used to serve different goals, very specific goals. So knowing your goal is usually the starting point of any kind of visualization. And then you need to know which kind of visualization types you can use to respond to address the goal you want to achieve. And then later on, you need to know specific controls of the visualization that can be used to better achieve the goal. The controls include the graphical devices I already mentioned. For example, the size, the width of the links, or the placement of the nodes, or the colors. Many kinds of things you can control in a visualization, and how would you use those controls to achieve your goals. So those are very specific aspects of making sociograms, and I wish you can keep exploring, not only in this week, but also for the rest of this class, to become familiar with them and then try to use your research project as opportunities of making decisions on those specific visualization processes. So you will see on this page many different kinds of very interesting visualizations that you will see, and then you can see there's so many ways to visualize networks very differently. And I want also to mention that no matter how perfect a visualization look like, for example, in this one is one of the very famous visualization made by New York Times. It looks very beautiful and perfect, but it usually takes a lot of iteration to produce such a beautiful visualization. So don't feel worried that the first trial of making a sociogram doesn't look as nice as this one, because it really takes a lot of effort to make it very usable sometimes or digestible visualization. So just keep trying and keep tweaking. A lot of tweaking going on, I think, in the visualization world, so that you can get familiar with different techniques and then apply those techniques in your own project, hopefully. And so I think that's the first part of this week, and you will get a chance to play with some tutorials if you wish to. This is not required, but I'm just trying to provide some additional information you can explore in this course. And again, feel free to share whatever you produce to the class, and then we can just learn. Even if I don't try it, I can learn from your work, and hopefully get informed by your work as well. And the next part, the second part of this week, is to playing with more mathematical side of social network analysis, and we're going to start from network level measures. Basically, those measures that can be used to describe a whole network, and then in this week's reading, chapter number 5 provides already a list of very commonly used measures like density, size. I think also include average path length. So those kind of measures could be very useful for you to describe a network that you're interested in studying. And And in this week, so reading this chapter is a great starting point to get familiar with these measures. And I also want to point out that you might have already read some of these measures in earlier readings. And just if that's the case, just use this opportunity as a way to kind of solidify your understanding. For example, what's the very official definition of the specific measure of density, and how does that get translated to intuitive understanding of density in your own research context. So I hope you can, even though you might have read those measures and you think you are familiar with them, just use this opportunity to connect the mathematical representation of these measures with the intuitive understanding of this measure, and with your very practical usage of this measure in your own context. I think that will be a very interesting exercise for this week when you're reading more about these measures. And here on this page, I highlighted a few things that we want to explore, but not necessarily covered in this chapter, so that you can understand there are different, especially a lot of decisions involved when you are computing this measure. For example, one example is you need to set up a threshold sometimes to filter a network. For example, I remember last week's example. There's a lot of links which has a weight of 0. So you need to kind of filter those edges and remove them from any kind of computation of density, so that you actually do not include them because their weight is 0. It doesn't make sense to include them. And there are a lot of other decisions you need to make. So when you're reading the chapter and also reading my post here, just please explore this kind of decision and reflect on your own research project, and to try to capture those critical decisions you need to make in SNAEd. So I think that's a great starting point for getting into the mathematical side of social analysis, and then try to understand how this could be applied in your own research context. And for the week's assignment and activities, and the first part you can just get a sense actually from reading this page is to read the chapter and then to build knowledge together. And by building knowledge together is basically to find a measure you like or you don't like. It doesn't really matter. And then do a bit of research on how it could be computed. You could Google it. For example, you can Google Gephi, density measure, directed network. You can find out how to compute this measure in Gephi. And then you can share the solution. By, for example, share the solution by, let me see. For example, the density, you can highlight this piece and then make an annotation, right? Make an annotation, say, this is a link that you can use that demonstrate how you can compute density in Gephi. Or if you're using R, you can just actually write the command of R here, so that other people can just learn by reading your contribution in the form of annotation. And then we can keep doing, and then kind of, it's like building a wiki of doing social analysis computation together this week. And we can keep doing this in later weeks as well. And I think this is a fun way to build our knowledge together, because when you try to do it, you might think it very differently compared to others. And hopefully we can have different perspectives that can contribute to this learning process, so that we can learn more as a group. And also the second part of the assignment is to do the data collection hands-on. You will find more information here. And if you have a question, again, feel free to post your questions in the Q&A channel of Slack. And then finally, when you got your data, when you know how to compute network level measures, feel free to share what you got, what you compute, and which kind of result you find that might be surprising or not surprising, and share them back to the Slack channel. And I hope that's, again, a very fun way to actually learn about social network analysis, which is through group collaboration and sharing. And I think that's all for this week, and hope you're enjoying a great week. And thank you.